welcome to your geometry week of March 1st. Welcome to March. Make sure at this time you do have your math notebook out and you're ready to take notes as you watch this recording. Remember, this is going to only help you when you go to do the graded assignments throughout the week. So taking notes is required, and it will help you when you go to do this week's assignments. I do have a quick warm-up I'd like for you to give a try in your math notebook. We've got a right triangle here, and we want to find the missing side y. And you are going to use a trig ratio. That's my hint, that you will use a trig ratio. Remember, SOHCAHTOA, TOA, to help you find that missing side length of y. So go ahead and click pause now, and when you're ready to check your work with mine, go ahead and click play. All right, so we have this angle right here labeled as 30 degrees. The other side, B, is not given to us. So we know that we need to use this angle here as our reference point. And we've got this side that is opposite to this angle, and then we need to find the side that is adjacent to that angle. So we've got opposite and adjacent. So are we going to use SOHCAH or TOA? If we've got the opposite and adjacent, we're going to use tangent, the TOA. TOA for having the opposite side and the adjacent. So let's go ahead and set up that ratio. So we would say tangent 30 equals, remember TOA is opposite side. The opposite side is going to be 5 over the adjacent side, which is y. And we need to solve for y. A quick way when you've got your unknown in the denominator, you need to move that to the numerator so that you can solve for it. So what I'm going to do is I'm going to multiply both sides by y. And that way the y's cancel out on the left side, or on the right side. Now we're left with y times tangent 30 equals 5. And we need to get y all alone, so I'm going to divide each side by tangent 30. Tangent 30. Go ahead and grab your calculator so that you can plug this into the calculator. You're going to plug in 5 divided by tangent 30. And when you do that, 5 divided by tangent 30, you should get, if you did it correctly, 8.66. We'll go 2 decimal places. And that's going to be our answer. Y equals 8.66. All right, so let's go ahead and move on now that we're a little bit warmed up thinking about some math. This week we're going to start on Unit 7. So this recording is kind of a little bit into the week. You guys should have already completed the Unit 6 quiz. So that should already be done at this time. And now we're going to be learning about Unit 7, Session 1, reviewing area of triangles and quadrilaterals. So Unit 7, Session 1 is probably going to be a lot of review for you. And then Unit 7, Session 2, we're going to be getting into finding the area of circles and regular polygons. So let's go ahead and jump right in. Triangles. Finding the area of triangles. This should be review. The area for a triangle, you're going to take 1/2 the base times the height. So here's your base and there's the height. The important thing that you take away and remember is that when we're dealing with height in triangles, you need the height to form a right angle with the base. So in order to have the correct height, you need that height to form a right angle with the base in order to be the correct height. So right here, this would be your height, and it forms, when it intersects the base, it forms a right angle, a 90-degree angle. What I don't want you guys to do is say that like this leg length that I highlighted in red, that's the height, because that's not true. The height needs to form a right angle with the base. So So keep that in mind as you're working throughout this week. So let's go ahead and find the area of this triangle. So just a reminder, area equals 1/2 base times height. So what is the base of this triangle? It's 12. It's the length from here to here. That's our base. And what is the height of this triangle? What is the height? Remember that height needs to form a right angle with the base. So that means the height is going to be this measurement from here to here. It would be 8 inches. It would not be 10 inches because those lengths do not form a right angle with the base. All right, let's go ahead and plug our numbers into the formula. 1/2, we're going to multiply 12 times 8. So you can take 12 times 8, you get 96, and divide that by 2 to get 48. And we don't want to forget units. That needs to be for area. It's going to be inches squared. So whenever we're finding the area, our units of measure, the units will always be squared when you're finding area. So please do not forget to use your units of measurement when you're solving problems this week. You will lose some partial credit when you're not including the units of measurement. That is part of the answer, so please make sure that you're including that. All right. Sometimes you might need to find the base length of a triangle before you can find the area of a triangle. So if we were asked to find the area of this triangle, let's say we were asked to find the area of the triangle, 1/2 base times height. Do we know the base length? We don't. We need to figure that out. Do we have enough information to do that? We do, and that's why we reviewed using the trig ratios for the warm-up problem. We can use trig ratios. So let's go ahead and find the base length of this triangle. I'm going to divide this into 2 right triangles. So let's focus on this triangle right here. And let's go ahead and focus on finding the base length from here to here. So from here to here. And actually we're not going to use a trig ratio. I don't know why I just said that. I meant to say Pythagorean theorem. So remember, we can use the Pythagorean theorem when we know 2 out of the 3 side lengths. So let's go ahead and find this length. We'll call this x, using the Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared equals c squared, where c squared is always the hypotenuse, and that's always the length opposite to the right angle. So our hypotenuse here would be 17. We're going to square that. Let's say that we're trying to, we'll call side A, call it x, and then we're going to add 15 squared. So let's do the math. 15, we're going to take 15 squared, which is 225, and 17 squared is 289. So then to solve for x squared, we're going to subtract 225 from both sides. Okay, so 289 minus 225 is 64. So we're left with x squared on the left side of our equation, 64 on the right. So to get x alone, we need to take the inverse or do the opposite of squaring x. So we're going to take the square root of both sides, and we get x equals 8. X equals 8. So the length of part of our base is going to be 8. So that's the length of part of our base. So it's 8. I'm just trying to show the length from here to here is 8. That looks like an 84, so I'm going to fix that there. So from here to here, we've got 8. Now we need to find the length of the other half of our base. So we're going to do the same thing to the other half of our triangle. Let's do that in a different color. So we know that the opposite side of our right triangle is the hypotenuse. So we're going to have 15 squared plus, we'll call this side x as well, equals 25. We're going to square So really, if you want to, you can type in your calculator 25 squared minus 15 squared to skip a step there. So we'll have x squared equals 400. So what I did was I typed in my calculator 25 squared minus 15 squared. I'm going to let my calculator do the work. Now we've got x squared equals 400. We need to take the inverse of squaring, which is taking the square root. The square root of 400 is 20, so x is going to equal 20. So the entire length of our base, we have now found it. From here to here is 8, and from here to here is 20. So what is the length of our entire base? What is the length of our entire base? I'm going to try to move this stuff. Oops, I just want to move this down. Over to the side there. The entire length of our base is going to be 20 plus 8, which equals 28. So now we're ready to plug into our formula to find the area. 1/2 base times height. What is our base? We just said it was 28. And what's the height of this triangle? Remember, the height needs to form a right angle with the base. So the height is going to be this measurement here, which is 15. So times 15, go ahead and grab your calculator, type in 28 times 15. You get 420, and we're going to take half of 420. And what do we get? You should get 210. Are we done? No, we need units of measurement. We would say inches squared, and then we are done. And then we are done. So to summarize what we did there, we were missing our base to plug into the formula for the area of a triangle. So we had to use what was given to us, and we had 2 sides of every right triangle, and thus we could use the Pythagorean theorem to help us solve. All right, I'm going to keep going, so if you need to take notes here, go ahead and click pause so you can do so. You will have a problem like this on your assignments this week. All right, so just to review the formula for different quadrilaterals to find the area of several different quadrilaterals, I have them all listed below, and this will be in your slides, your lesson slides this week. To find the area of a side or a square, you're just going to multiply one side times the other because all 4 sides are the same, so it's really the same as saying base times height. Same for a rectangle, base times height. To find the area of a parallelogram, you multiply the base times the height. And again, it's very important, with just like it was for a triangle, that when you use the height of a parallelogram, that it's forming a right angle with the base. So the height of a parallelogram must form a right angle with the base. This length from here to here is not your height. The height must form a right triangle with the base, or right angle with the base. Same with a trapezoid. So to find the area of a trapezoid, you're taking 1/2, you add up your 2 bases and multiply it times the height. The height, again, must form a right angle with the base. And then last but not least, the rhombus. To find the area, you multiply the diagonals times each other, and then multiply that by 1/2, or divide that by 1/2. So the diagonals are when you draw a line from one vertex directly opposite to the other vertex. Same thing with the other 2 vertex. That's what your diagonals mean. So let's practice finding some area. I'm going to go to the next slide. If you want to click pause, go ahead and do so now. Area of a parallelogram. Do I have so remember, area of a parallelogram, base times height. Height must form a right angle with your base. So here's not a question where it says, find the base of the parallelogram if the area is 96 inches squared and the height is 8 inches. So here we're given the area and we're given the height. We need to find the base. So make sure when you read a question you understand what you're given and what you're trying to find. So here we're trying to find the base. We know the area is 96 inches squared and the height is 8 inches. So, area of a parallelogram, the formula is base times height. Base times height. So let's substitute in what we are given. The area is 96 inches squared. We don't know the base. I'm going to keep that as b, but we do know the height is 8. So now how do we solve for b? b is being multiplied by 8, so we're going to divide each side by 8. And what do we get? 96 divided by 8 is 12 inches. So that would make the answer 12 inches. So you're going to find this week, not only are you finding area, but you might be given the area and you need to find like the base or the height. All right, perimeter. We haven't talked much about perimeter. Perimeter is when you just add the lengths around your quadrilateral or the shape you're working with. So here, if we know one side, we know the length of the other side. And if we need to find the perimeter and we're adding together some variables, we can do that. If we have like variables, you would just add and simplify the like variables. So what do we have here? We've got x minus 1 plus, oops, forgot the plus in there. We're just going to add up all the sides. X plus 1 plus x plus minus 1 plus x plus 4. I don't really need the parentheses around there. Plus x plus 4. I'm going to take those parentheses out. I don't know why I added those. You can have them or you don't need them really. So what are we going to do? Add our like terms. How many x terms do we have? 1x plus 2x plus 3x. We've got 4 x's. So you're really just combining your like terms here. We've got 4 x's. And then we've got negative 1. We're taking away another 1. So we're at negative 2. Add 4. So negative 2 plus 4. We're at positive 2. Plus another 4. We're at 6. So we've got 4x plus 6. That's all we can do. We would stop there. So when we're finding the perimeter and we're given some variables, you're just adding your like terms. That's all you need to do for a problem like this, is just add your like terms. I'm going to move on. Let's keep going here. I want to get to a different one. Kites. Kites. So to find the area of kites, we're going to multiply the diagonals together and divide those by 2. That's how you find the area of a kite. All right, so let's look here. It says find the missing diagonal of a kite with an area of 112 square meters if the other diagonal is 16 meters. So again, here you just need to make sure you set up your equation correctly and then solve for the unknown. So remember, here we go. This is the formula we need to use. Multiply the diameters together and divide by 2. So area equals diagonal 1 times diagonal 2 and divide that by 2. Always helps to just write down the generic or the general formula to find the area of whatever shape you're working with and then fill in the given information. So here the area is 112. We don't know one of our diagonals and the other one is 16 divided by 2. All right, our whole goal is to solve for the diagonal, our first diagonal, the D1. How do we do that? Whenever there's a denominator, you want to get rid of that denominator number first. So since all the right side is being divided by 2, to get rid of the 2, you want to do the opposite of dividing. So we're going to multiply each side by 2. That cancels out the 2's on the right side. So now we've got 16 times D1. You can put D1 times 16. It doesn't matter. 2 times 112 gives you 224. D1 is being multiplied by 16 to do the opposite to solve. We're going to divide each side by 16. So 224 divided by 16. And what do we get? D1, the diameter, 224 divided by 16 is 14. You always want units of measurement. We were talking about meters, so the length would be 14 meters. And we're done. All right. Find the area of a rhombus. You will do a problem just like this on your assignments this week, so pay close attention. How do our diagonals cross? How do they intersect? They intersect at a right angle. So keep that in mind as we're working on this problem, that the diagonals are intersecting at a right angle. We need to find the area of the rhombus. So if we go back to find the areas of rhombus, the area of a rhombus is the same thing that we just did. Diameter times the diameter. Not the diameter, I'm sorry. The diagonal times the diagonal divided by 2. So let's go back here. So to find the area, we need to take the diagonals and multiply them times each other and divide that by 2. Do we have the lengths of our diagonals? We know parts of our diagonals, don't we? We know parts of our diagonals. So we need to find the other lengths of our diagonals. And in a rhombus, you have a special pattern, and that's the length of one of your, the diagonals are going to bisect each other. So from here to here is going to be 3 centimeters. So since they bisect, it means this side is also going to be 3 centimeters. And same with the other. This one's going to be 8 centimeters. So what is the length of our longer diagonal? 8 plus 8 is 16. The length of our smaller one, 3 plus 3 is 6. And then we'll divide that by 2. So 16 times 6, I got 96. Divide that by 2. And we have our area. Area equals 48. Would I be done if I said area is 48? No, we need units of measurement. So we would say it's 48 centimeters squared. All right, so you're going to be using pi in, I believe that's session 6 as well, to find the area of circles. So pi, we're going to use 3.14 to represent pi, or you can use your calculator and use the actual pi on your calculator. Just so that we know what pi is, pi, if you take the circumference of any circle and divide it by the diameter, that's how we get pi. That's how we get that number 3.14159, and then it keeps going and going and going. It's a non-terminating decimal. And to get that number, we divide the circumference over the diameter. That's how we come up with pi. Parts of a circle, just to review, the radius is from your from the center of your circle out to one of the sides, any of the sides, that's your radius. Diameter goes through the center, all the way across to the opposite side of the circle. That is your diameter. That is your diameter. I should probably use a different color for that. Could have used a straight line. That is your diameter when you go straight through. All right, that's your diameter. And the diameter is equal to 2 times the radius. That equals your diameter. So just a review on that kind of stuff. Area of a circle, pi times radius squared. The circumference is pi times diameter. And remember, diameter is 2 times the radius. So if really quick, let's do should be review. I want to get to regular polygons as quick as possible. Find the area and circumference in terms of pi. This is what I really want to focus on with you. What it means when we say to find the area or find the circumference in terms of pi. So when we say in terms of pi, that means you're going to keep pi, the symbol pi, in your answer. So let me show you an example here. So to find area, we know area equals pi r squared. So when we say find it in terms of pi, we're going to keep pi in our answer. What's the radius of this circle here on the right? If the diameter is 12, the radius has to be half of that. So the radius would be 6. So area equals pi, radius is 6 squared. Okay, so let's simplify. 6 squared is 36 pi. To solve in terms of pi, we leave pi, the symbol pi, in our answer, so we would be done. If we needed to solve in terms of pi, you leave the symbol for pi in your answer. So the area of that circle over there on the right would just be 36 pi. And we would be done. To find the circumference, let's see here. The circumference equals pi times diameter. We're going to solve in terms of pi, so we're going to leave pi in our answer. The diameter is 12. 12 times pi, we'd be done. We leave pi in the answer. That's what it means when we say solve in terms of pi. You leave pi in the symbol for pi in your answer. Okay. Regular polygons. What does that mean? So regular polygons mean that all the sides are going to have the same measurement and all the angles will have the same measurement. So I could put ticks in all the sides here to show that they're all have the same length. That's what a regular polygon means, and every angle is also going to have the same angle measurement. Same length of the sides. All sides are congruent. All sides are congruent, and all angles are congruent. That's what it means to be a regular polygon. All sides are congruent, and all the angles are congruent. That's what it means to be a regular polygon. We're going to learn how to find the area of a regular polygon. So before we do that, let's learn the parts of a regular polygon. That we're going to see some terms of the parts of regular polygons in our area formula for regular polygons. We already know what the radius is. It's the same thing for a regular polygon, where we go from the center of the polygon out to the side, any side. From the center to the side, that's the radius. Here's a special word, apothem. Apothem, right here. Apothem is when you go from the center and form a right angle with the side. Ignore the, I wish this wasn't here, the circle along the outside. Ignore that black circle. That's kind of there for a different reason. The apothem, what's important is that the apothem forms a right angle with the side of the polygon, just like we had to do for this height for triangles and heights for parallelograms. The apothem has to form a right angle with the side of the polygon. So this is very important. The apothem forms a right angle with the side of the polygon. That's what an apothem is. And we're going to see apothem on the next slide because I'm about to introduce how we find the area of a regular polygon and what the formula is. Here we go. The formula, write this down in your math notebook. A, the area equals 1/2 A, small case a, times capital P, where little small case a stands for apothem, and the uppercase P stands for perimeter, the perimeter of your polygon. So it's important that you understand what the variables represent in the formula to find area of a polygon. A, area, equals 1/2 A times P. Let's go ahead and use that. Let's find the area of this polygon right here. Area equals 1/2 A times P. What is the apothem? The apothem, remember, has to form a right triangle with the side of your polygon. It goes from the center of the polygon and forms a right angle with the side. That's your apothem, so it's going to be 5.5. What is the perimeter? What is the perimeter? Well, if one side length is 8, and how many sides do we have? And they're all going to be congruent. We've got 1, 2, 3, 4, 5 sides, so the perimeter will be 8 times 5, which is 40. So now we can plug this all into our formula. 1/2 5.5 times the perimeter is 40. So I'm going to multiply 40 times 5.5. I get 220, and then I'm going to take that and divide that by 2. And that's going to give me my area. 220 divided by 2 is 110. Remember, area, we need to use units of measurement. So area would equal 110 inches squared. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. I want to get in one more example for you guys. All right, what do we do to find, here we go. Sometimes you are not given your apothem length, and you need to find the apothem in order to find the area. So if you're asked to find the apothem and you're given the side length, this is how you find the apothem. You will have a problem just like this in your homework, so pay close attention here. So if you are asked to find the apothem length and you're given a side length, this is what you are due when you're given a side length. All right, so what we need to do is think about the fact that we've got a right triangle when we're dealing with the apothem. So this side right here represents our apothem, right? That's our apothem. And I highlighted, we've created a right triangle here. And we know that once we have a right triangle and a given side length, that we can use some of our trig ratios to help us find side lengths. So I'm going to redraw this right triangle right here. Whoops. So we know the entire side length is 10, so the base of our right triangle that I highlighted is going to be half of that, so it's going to be 5. We want to find the apothem. I'm going to put A to represent the unknown. And now we need an angle measurement. We need this angle measurement up here at the top. So this is how we're going to find that angle measurement. That angle measurement is going to be always use this formula, 180 degrees divided by the number of sides, and that's going to give us that angle measurement. So how many sides do we have here? 1, 2, 3, 4, 5, 6. This is a 6-sided polygon. So what we do is we take 180 and divide it by 6, and I get 30 degrees. So I know that this is a 30-degree angle. So you can either use, if you want, you can use a trig ratio, SOHCAHTOA, or in this case, you could use patterns of a 30, 60, 90 triangle. It's up to you. I'm going to go ahead and use a trig ratio. We want to find the apothem length, so we're going to start up here. This is our reference. We're standing at that angle. We have the opposite side, and we need to find the adjacent. Opposite over adjacent is TOA, so we're going to use the tangent ratio. So I would set up tangent 30 equals opposite over adjacent, just like the warm-up problem we did. Now to solve for A, we're going to divide or multiply each side by A to get that A out of our denominator. Then we can divide each side by tangent 30, because now we really have A times tangent 30 equals 5, so we're going to divide each side by tangent 30. So I'm going to let my calculator do the work. I'm going to type in 5 divided by tangent 30. 5 divided by tangent 30, and it looks like I get 8.7 when I round. 8.7 when I round. So my apothem here is equal to 8.7. My apothem is equal to 8.7. That's how you find your apothem lengths, and then we could go ahead and find the area of this polygon. But I just wanted to point out how you find the apothem length when you're given a side length of a regular polygon. you need to create that small right triangle. You need to create that right triangle. And using the trig ratios, we can find the length of then our the hypotenuse, which is, whoops, not the not the hypotenuse. The apothem is not the hypotenuse. We would find this length from here to here is our apothem that we're trying to find. The apothem has to form a right angle with the base. So that's where we're going to stop today. I know you guys are ready for your key phrase assignment. We are in the week of, we're doing the week March 1st. And make sure you have the correct date lining up with the key phrase assignment. The week of March 1st key phrase assignment. Describe what an apothem is. You need to use the definition that we went over in the recording. So please use the definition we used in the recording. And there are several questions that you will see in your assignments this week that are just like problems we practiced. So as long as you took good notes, you will get those questions correct this week when you see them on your assignments. Have a great rest of your week, and please let me know if you need any help.